All right, let's take a trip. We're heading about 60 million light years away, out to the Coma Berenices constellation, right on the edge of the Virgo cluster. Our destination? A galaxy called Messier 85. Now, at first glance, you might think it's just another fuzzy patch of light. But this galaxy, M85, it's holding on to a really fascinating secret. You see, it belongs to a class of galaxy that, for a while anyway, some of the top astronomers thought might not even be real. So how on earth can a galaxy be hypothetical? And that's a quote from the man himself, Edwin Hubble. You know, the guy who literally wrote the book on classifying galaxies. Back in the 1930s, he created that famous tuning fork diagram that sorts galaxies by their shape. But even he started to doubt one of his own categories, the S0, or lenticular galaxy. He basically thought, maybe this is just a hypothetical bridge between other types. And here it is. This is our galaxy, Messier 85. I mean, it looks pretty real, doesn't it? So that's the big question we're tackling today. What was it about galaxies like this one that made the great Edwin Hubble so darn skeptical? Let's dive in. Okay, so to figure this out, we first have to get a handle on what exactly we're looking at. M85 is kind of the poster child for this SO, or lenticular class of galaxies. And that name, lenticular, is actually a really big clue. A lenticular galaxy is sort of a cosmic hybrid. It's got the central bulge and the flat disk that you'd see in a spiral galaxy like our own Milky Way. But, and this is the key part, it's missing those beautiful, iconic spiral arms. And even more important, it's basically run out of gas, the cold gas and dust it would need to make new stars. Think of it as a retired galaxy, all quiet and smooth. That word lenticular, it just means lens-shaped. If you can picture taking two dinner plates and putting them together rim to rim, that's the basic shape. A smooth, featureless, lens-like disk packed with old stars. And this right here, this was Hubble's big problem. These things are masters of disguise. If you look at one face on, it just looks like a round, fuzzy, kind of boring elliptical galaxy. But if you see it from the side, edge on, it looks like a spiral galaxy that just forgot to grow its arms. They were just incredibly tricky to pin down, which made them seem super rare, maybe even non-existent. But here's the amazing twist. When we look with modern telescopes and do massive surveys, the story completely flips. Just take a look at this chart. See that blue bar? That's the lenticular galaxies. It's way higher than the bar for elliptical galaxies, especially in crowded places like galaxy clusters. It turns out these so-called hypothetical galaxies aren't rare at all. They're actually a huge part of the universe, hiding in plain sight this whole time. So if they're everywhere, where do they come from? Well, all the evidence points to this really dramatic transformation, a story about a galaxy getting robbed of its ability to make new stars. And this is the core of the mystery. A spiral galaxy is like a bustling city, constantly building new things, full of raw materials, gas and dust. An S0 galaxy, like M85, well, the city's gone quiet. The factories are shut down. So what happened? Where did all the gas go? The leading theory is something with a seriously cool name, RAM pressure stripping. Here's how it works. Picture a spiral galaxy moving at insane speeds through a giant, invisible cloud of superhot gas in a galaxy cluster. That intergalactic gas acts like a headwind, a wall, and it slams into the galaxy's own supply of cold gas, stopping it dead. But the stars? They don't feel that gas, so they just keep right on going. It's like that old magic trick where you whip the tablecloth out from under all the dishes. The dishes, the stars and the disk, stay put, but the tablecloth, the gas, gets left behind. What's left is a stripped-down, gas-poor, lenticular galaxy. That whole stripping process explains why there aren't any new stars, but it's not the whole story. To really get to the bottom of M85's secrets, we have to look at it in a type of light our eyes can't see. We need to look with X-rays. So astronomers pointed one of our most powerful tools, NASA's Chandra X-ray Observatory, right at M85. This let them see all the high-energy stuff happening inside the galaxy, giving them a totally new picture of what it's made of. And what they saw was fascinating. The X-ray glow from M85 is coming from three main things. As you can see here, about 45% of it is this big halo of hot diffuse gas, probably leftovers from that violent stripping event. The other 55% comes from pairs of old, dead stars called low-mass X-ray binaries, and that is the classic signature of an old, evolved galaxy. But that's not all they found. When they combined the X-ray data with images from the Hubble Space Telescope, they found something truly bizarre right at the very heart of M85. And this is where the mystery really deepens. So, when we look at the core of most galaxies, we see one single bright point of light. That's the nucleus. But M85? It's different. It doesn't have one bright point. It has two. A double nucleus. What is that about? So what could possibly cause that? Well, the best explanation isn't that there are two cores, but that we're seeing an illusion. We're likely looking at a single disk of stars that's orbiting the center in a wobbly, off-center path. From our point of view, the brightest parts of that wobbly orbit just happen to look like two distinct points of light. And a structure like that is a huge red flag that this galaxy went through a violent merger in its past. Now, for a weird, wobbly disk like that to exist, it needs something incredibly massive at the center holding it all together with gravity. And at the center of a giant galaxy, that something should be a supermassive black hole. But when astronomers actually measured the mass of whatever was at the center, they got a massive shock. What they found was that the black hole couldn't be any bigger than about 96 million times the mass of our sun. Now, I know, that sounds huge, but for a galaxy as big as M85, that is shockingly small. It's like finding a pebble where a giant boulder should be. Just for comparison, the black hole in the galaxy M87 is over 6 billion solar masses. In fact, the measurement was so low that it's statistically consistent with zero. Think about that. It's possible there is no supermassive black hole there at all. So you have a galaxy that was stripped of its gas, it's got evidence of a messy merger, and now it might even be missing its central black hole. M85 is basically a cosmic crime scene. So, let's pull all these clues together. Let's close the case. What's the final verdict on this strange, supposedly hypothetical galaxy? The case file is pretty clear. Messier 85 is almost certainly an old spiral galaxy that got into a fight and had its gas violently ripped away. The evidence of a merger is written all over it, from its weird outer shape to that bizarre double nucleus. And right at its heart is a black hole that's either a lightweight or it's just gone. You know, one astronomer once said about lenticular galaxies, they're hard, they're a complete pain. And you can see why. Hubble was right about one thing. They are incredibly tough to classify. But it's that difficulty that hides just how important they are to understanding the universe. So M85 isn't hypothetical at all. In a way, it's a ghost. It's the ghost of a spiral galaxy, caught in a snapshot, showing us exactly what happens when a galaxy like ours has a really, really bad day in a crowded cosmic neighborhood. And that leaves us with one last kind of mind-blowing thought. Our own Milky Way is on a collision course with the Andromeda Galaxy. And eventually, our whole local group of galaxies is probably going to fall into the massive Virgo cluster. So when we look at M85, are we getting a little sneak preview of our own galaxy's ultimate fate billions and billions of years from now? Something to think about.